All right, here we go. All right, 4, 4, C. So today we're going to talk about manipulating these sine and cosine graphs by shifting them either side to side or up and down. We also call those translations. And so how can we control the equation to make it do what we want? If we want the equation to go one direction, how do we make that happen? And so this goes back to what we were learning when we very first learned how to do graphs. We learned the acronym INSERT. Okay, N is you first have to learn how to do a normal graph. So on the very first day of this unit, we learned how to do normal sine and cosine. Okay, then S stands for a stretch, which affects the scale. And so we learned how to stretch the scale. And we adjusted our scale. If we had to adjust our y-axis or our x-axis, we learned how to do that and how to label. Kind of at the same time, we talked about reflections and how the negative flips it upside down. So NSRT. The last thing you would address is a translation, either up or down or side to side. So let's talk about how that works. All right, y equals a sine parentheses b. We've already learned what the a will tell us about adjusting the scale of the y-axis. We've learned what the b tells us about adjusting the scale on the x-axis so that we can know when our period or cycle ends. If you add another parentheses following that, and then have your variable x, and then plus or minus, it could be either, c. That plus or minus c is going to control moving the graph side to side, left or right. And so, oops, this one right here is left or right. Now remember, when we learn how to do graphing, if it's inside parentheses, that's the thing that goes left or right. But it's opposite of what you might intuitively think. The plus things always move it to the left. So that was for parabolas, for square roots, for logarithms, for all the graphs we've learned. Plus in the parentheses means it goes to the left. Minus in the parentheses means it goes to the right. How do we control up or down? When it's outside the parentheses. All right, and so up or down would be we have a plus or minus on the outside. And then we have D. And that part right there is controlling the up and the down translation. And the same thing is true for cosine, so there's no different. It would be A cosine B followed by a parentheses, x plus or minus C plus or minus D. That extra parentheses has to be there if you think you're moving it side to side. Okay, if you think you're moving it side to side, that extra set of parentheses has to be there. Okay, so let's practice how this is going to go. So we're going to do y equals our first example. So we'll need 4 of them that are going to be on a grid. We'll do 4 of those, and then I have a few more notes to add to the bottom when we get through all 4. So let's do 2 sine 2 pi minus x. Now, right away, we spot that there is a, oh, I'm so sorry. Let's try writing it in the right order. 2x minus pi. I'm so sorry. There we go. Okay. Just a little dyslexic moment there. Okay. We notice that right away we spot the minus. And so right away, we think, oh, okay, I see this minus. That means I'm going to be going to the right. However, if you even think that you might be going to the right or left, you've got to investigate whether the necessary parenthesis is there, and it's not in this problem. Okay, we are missing a parenthesis that should be right there between the 2 and the x, and it's not there. So we've got to put it there before we do anything else. And we're going to do that with factoring, which is like GCF. So what we do is we divide by 2, and we rewrite the equation. And so it's going to look like this. We still have our 2 on the outside, parentheses. We have our 2, then we insert parentheses, and then we put what comes after you divide by 2. So dividing by 2 means I'm left with plain x. And then when I divided pi by 2, I'm left with pi over 2. Okay, now that is written in the correct form. So if you even have an inkling that you think you might be moving left or right, you have to do division to insert the parenthesis there so that everything works out correctly. Okay, so that's the first step. Now we're just going to follow our insert model. So N, draw normal. S, adjust your scale. R, reflect if needed, and then T would be translate at the end. So first I'm going to start with normal. This is a sine graph. So I'm going to do normal sine graph, and I am going to count by 2's this time, just because I don't have enough room to count by 4's. Okay, I am going to count by 2's. Again, you control how you want your scale to be. Just make sure you do it consistently. So for this purpose, because I don't have as long of a space as I did before, instead of counting by 4's, I'm going to count by 2's. So there's my sign. Now I'm going to label my scale. My scale says the amplitude should be 2. So maybe I think I'm going to move my upper and lower dots so that I can move it up to 2. I think that will be a little better. Okay. All right, so now I'm going to write my scale. My scale will be 2 on the y-axis and negative 2. Then I draw the scale of my x-axis using the value of the period. So I maybe have to do a little calculation over here. The period will be 2 pi divided by the number 2. Okay, that's the number 2 that goes right there. That works out to have the end of the cycle be 1 pi. So my labeling will have the end of my cycle be 1 pi. Beginning is 0 pi. Center is half pi, a quarter pi, and 3/4 pi. And I'm going to draw my nice sine wave. Oh, that was not so good. Try again. Okay, got my nice sine wave. Okay, I've done N for normal. I've done S for adjusting my scales. There is no reflection, so now I'm up to T for translation. I know that I am moving to the right because of the subtraction sign, but I just need to know how much I'm moving to the right. Okay, I am moving to the right the value of pi over 2. So I look at my scale, and I see that the value of pi over 2, which is the same as half pi, on my scale is worth 4 tick marks. 4 scale marks gets me to pi over 2. So I need to take this entire graph, and I need to slide it to the right 4 tick marks. Everything needs to move over. Now you've got notability, so you can use your scissors feature. You can circle it and move it over. Do not move the scale markers, though. The scale markers stay where they're at. They stay fixed. What you're moving is the graph itself. Now, I don't have that feature on this app that I'm using, so I'm going to have to draw mine by hand, but I'm going to slide everything over 4 whole tick marks. Okay, every piece of this graph is going to slide over 4 tick marks. So the result is going to look like this. Okay. Everything is moving over 4. And so my graph now looks like this. And then I'll use my highlighter since I can't use scissors on mine. Sorry about that. Okay, I'm going to use my highlighter to highlight where the final graph ended up. Okay, there is my highlighted piece. Now, moving things side to side does not in any way affect the domain or range. The domain is still all real numbers. And the range is still -2 to 2. Okay, so my domain is still all real numbers. My range is -2 as a low, +2 as a high. Okay, but you probably dragged your graph over. Just when you drag it, don't drag the scale markers. The scale markers stay fixed. Any questions about that? Okay, let's try another one. Okay, let's do y equals -3 cosine parentheses 3x plus pi. Okay, again, I think, oh, I've got an inkling that I'm going to be moving this thing to the left. But the parentheses that aren't there need to be there. So I need to do a division by 3 to work this out. So y is going to be equal to -3 cosine, the 3, and then the new set of parentheses that I'm introducing. When I divide by 3, I get plain x, and I get pi over 3. Once you've done that insertion of the correct parentheses, then you're ready to follow your insert protocol. So I'm going to draw a normal cosine, but that's reflected upside down. So that's going to start down there, and I'm going to count every 2. Okay, there is the 5 dots. That would form a cosine reflected upside down. Then I'm ready for my scale. My scale will be -3 to 3. On my x-axis, I'll have to figure out my period. And so my period is 2 pi divided by that number 3 that we took out right there. And so 2/3 pi is the end of my cycle. So the end of my cycle is 2/3 pi. And so the beginning is 0 pi, middle is 1/3, middle of that is 1/6, and then 3/6 when I triple it, which is half. All right, so my cosine graph is pretty tall. And make sure you turn your corners on your cosine graph. So this is the NSR. I have done the normal, I've done the stretch of my scale, and I've done the reflection. Now I'm ready for the translation. This translation is plus pi-3, which means left. But how many do I go left? Well, if I'm looking at how many tick marks it is to the right for pi-3, to the right for pi-3 would be 4 of my tick marks again. And so, but I need to go left. So I'm going to pull every single dot to the left 4 tick marks. All of them are going to go to the left. Okay, so count, either drag them or move them physically. Everything should move 4 tick marks to the left. All right, so that means my new drawing will look like this. If I move it 4 to the left, 4 to the left, 4 to the left, and this one. So the new position of my cosine graph looks like that. And I'm going to highlight it to show that this is the new position. Okay, 4 to the left. Again, moving it left and right does not have any impact on the domain or the range. The domain is still all real numbers, and the range for this one, -3 to +3. Any questions about left and right? All right, so let's talk about up and down. Okay, all right, so moving this up or down, let's see, let's do y equals cosine half x and the parenthesis -2. Okay, 5 cosine half x and the parenthesis -2. So I can tell this one is not going to be side to side because the -2 is outside of the parentheses. So I don't have to do all that fancy stuff about inserting a parenthesis. I only have to do that when I have a left or right. All right, so let's graph a normal. And because this has 5 as my amplitude, I'm going to count my scale on my y-axis by 2's. All right, so this is going to be 2, 4, 6. And so I need to put 5 smack dab in the middle of 4 and 6. And again, I'm going to count every, so 5, -5 is going to be about right there. So, about like this. All right, so there's my graph. Now I need to label the x scale using the period. So period should be 2 pi divided by half, which is the number that's right in front of x. So 2 pi divided by half works out to be 4 pi. So my cycle should end at 4 pi. So let's label that appropriately. So 4 pi, 0 pi, 2 pi in the middle, 1 pi, 3 pi. Okay, so we've done n, s, there's no reflection. We've done the normal graph, we've adjusted our scale, no reflection. Now we're ready for the translation. This translation says to drop it down 2. Okay, I need to go down 2 units, 2 tick marks. So kind of keep track as you go down. My amplitude is 5 right now. I need to move that down 2 units. So how high is that going to be now? If I move it down 2, what's that new value? It's going to be 3. It's going to be 2 down from what it was. You can just drag yours down 2, but I'm going to draw mine down 2. So everything is going to move down 2, down 2, down 2, and down 2. So my new graph is slightly lower than my original graph was, and I'm going to highlight the position of my new graph. Okay. Now, this does not impact the domain, but it does impact the range. So, domain, still all real numbers. The range started out as -5 to 5. That was the value of the range. But I dropped this whole graph down 2, which affects the range. And so the quickest math way to do that is to write -2 under both of those numbers and come up with the new range. So the new range will be -7 for a low and 3 for a high. So the old range is gone. and the new range is -7 to 3. However, that does not change the amplitude. The amplitude was measured from the original graph. The amplitude is still considered to be 5. Okay, the amplitude is set. Only the range is affected by the shift to have it drop down to be -7 to 3. Any questions about the range? Okay, you might need to add another page because I think you're probably out. I need to add another page also on mine. Okay. All right, this will be our last one that we do on graph paper. Oops. Okay, y equals negative sign (2 pi x plus 3). Okay, negative sign 2 pi x. Okay, let's do a normal negative sign 2 pi x plus 3. Here is a normal reflected sign. Okay, the scale is -1 to 1 on the y-axis. Now let's figure out the x scale. So we'll do period, and the period will be 2 pi divided by, now what do I divide by for this one? What do you think? What do I divide by? I divide by 1, I don't divide by 1. I have to divide by the value that's in front of x, which is the b value, okay? So I'm actually dividing by not just 2, but I'm dividing by all of that number. So 2 pi goes under there. So the result is just the number 1. No pi, just the number 1. That's fine. So then our scale starts at 0 and ends at 1, but there's no pi's on it anymore. The pi reduced away. So my scale is 0 and 1, which means the center is 1/2, and then 1/4 and 3/4. Okay, so that is normal, reflected, and scale adjusted. Now we're ready to translate this in what direction and how much? Up 3. So all of these dots you need to drag up 3. So I'm going to pull this up to 3. I'll pull the one below it up 3, up 3, up 3, and up 3. And so the new graph of the sine wave is 3 units higher than it used to be. Let me highlight where that ended up. It's my final graph. Just make sure you don't drag your scale. All right, keep your scales fixed. Only drag the graph itself. So let's figure out how that impacts the range. It does not impact the domain. Nothing you can do would impact the domain. The domain is still all real numbers. But the range now used to be -1 to 1. We are now adding 3. So we're going to add 3 to the low number and the high number. And so this now becomes a range of 2 to 4. So I'm going to cross out the old range, and the new range is now 2 to 4. Okay, any questions about side to side or up or down? Okay, last example. The last example is a word problem. Word problems should not be done on graph paper. All right, so let me show you. Anytime you are now going to be doing a real life situation, you're going to sketch it on regular paper or off of a graph paper. All right, so an example of waves, the easiest one is maybe to think of water. So we're going to talk about the tide. And the tide follows a wave model. So let's look at 3.8 cosine pi sixths parentheses t minus 9 parentheses plus 5. Now that looks terrible. There's a pi, there's a 6, there's a decimal, there's all kinds of stuff going on there. But it's not so bad if you follow the insert model and don't try and get it on graph paper. Just freehand it. So let me show you how to freehand it, okay? All right, so cosine, let's draw our 5 cosine dots, freehand. Don't worry about getting it onto graph paper. Just draw 5 cosine dots. Okay, these 5 cosine dots, we know it's not really a V shape. We know that these 5 cosine dots are like that. Okay, and that the cosine wave shape would look like this. That is a normal cosine graph. Again, don't worry about drawing it on graph paper. Now let's get some scales on here. Even though we're not on graph paper, we can do it on scales. Okay, what's the high and the low? How do you determine the high and the low of this graph? 3.8 and then negative 3.8. Okay, we're not going to worry about doing it on graph paper because it's really hard to draw 3.8 on graph paper. It's super hard. So instead, we're just going to draw it like this. Okay, what about the cycle side to side? Okay, the X scale cycle. Can we figure out the period? Okay, let's do a little math here. Period should be 2 pi divided by what number? Not 1 over 6. Why just 1? It's not 1 over 6. What's the number in front of the variable? No, separated by the parentheses. The B value is always separated by the parentheses. Did you forget the order of how things go? This is A, this is B, this is C, this is D. What is B? Pi 6. Not just 1/6, pi 6. All right, so 2 pi divided by pi 6. Well, how do we do the math on that? Multiply by the reciprocal. So 2 pi times 6 over pi. What does that turn out to be? It turns out to be 12. That means the cycle ends at 12. So 0 is the beginning, and the cycle ends at 12. What are we talking about here again? What real life situation? Tide? So 12 what? How long is the cycle of the tide? 12 hours, exactly. Right? The cycle of the tide is 12 hours. All right, so we don't need to force this onto graph paper. We freehand it. All right, now we need to slide this thing left and right and up and down. Okay? What does the C tell me to do? Right 9. Okay? This tells me to go right 9. Now, we're not doing this on a graph, so you're not going to slide at 9. You are going to add 9 to these numbers. Okay, when we add 9 to the numbers, we get some new numbers. And we get 9 and 21. Okay, so 9 goes here. Oops. And 21. That's 9 o'clock and 21 o'clock, which is military time. Okay, do you guys know what 21 is? Like, what time of day is that? That's 9 p.m. So this is 9 a.m. and 9 p.m. Okay, what does the plus 5 mean? Okay, up 5. Which numbers get moved up 5? Okay, the 3.8. So up 5 up 5. All right, so we get some new numbers for that too. So what's the lowest number if I add 5 to that? No, negative 3.8 plus 5 is not 2.8. Okay, it's 1.2. And the higher number is now 8.8. Okay. This graph tells a story. At 9 a.m., okay, which is here, how high is the tide? 8.8 meters. What about at 9 p.m., which is 21 hours later? How high is the tide? 8.8 meters. So when is high tide? 9 a.m. and 9 p.m. Okay, when is low tide? Okay. Okay, we got to figure out halfway between 9 and 21. Okay, halfway between 9 and 21 is 15. Okay, well, what's 15 o'clock? 3 p.m., so that's 3 p.m. And low tide at 3 p.m. is how much? 1.2 meters. What would mid-tide be? Okay, we've got high tide, we've got low tide. When would it be in the middle? Well, what's between 9 a.m. and 3 p.m.? 12 noon, right? So this is noon right here. Okay, and then it would also be back to mid-tide at 6 p.m. Also, it happens twice. Could you figure out the middle of the tide? Okay, that's some good math. Can you figure out the middle of the tide? Ooh, 5. How'd you do that? Exactly. The middle is exactly 5. Is there another way to figure that out? Exactly. Add the high and low, which gets you 10. Divide by 2, gets you 5 again. That also gets you the middle. Okay, so I would encourage you, any real life problem, freehand draw it. Don't try and force it onto a graph, because most of real life problems are going to be decimals, which are hard to draw on a grid. So just freehand draw it and change the numbers by adding or subtracting the numbers as you go.